Hello everybody, my name is Lekhana Anand. I'm from ISCB. My topic is artificial neural networks.
Hello everybody, my name is Kirtana P. I'm from ICB. My topic is clustering in machine learning. What is an artificial neural network?
An artificial neural network is a machine learning model inspired by the structure and functioning of the human brain. It consists of layers of interconnected neurons that process information. Each neuron receives input, processes it, and passes the output forwards. The ANNs are capable of learning patterns from data through training. They are widely used in applications like image recognition, speech processing, and prediction systems.
How does an ANN work?
ANN works by taking input data and passing it through multiple layers, input, hidden, and output layers. Each connection has a weight which determines the importance of the input. Neurons apply activation functions to produce output. During training, the network compares predicted output with actual output. Errors are minimized using algorithms like backpropagation, which updates the weight to improve accuracy.
What are the main components of ANN?
The main components of ANN include neurons, weights, bias, activation, functions, and layers. The input layer receives data, hidden layer processes it, and the output layer gives result. Weights control the strength of connections between neurons. Bias helps shift the output to improve learning. Activation functions introduce non-linearity, allowing the network to handle complex problems.
What are the activation functions and why are they important?
Activation functions determine whether a neuron should be activated or not. They convert the weighted sum of inputs into an output signal. Without activation functions, ANN would behave like a simple linear model. Functions like ReLU, sigmoid help the network learn complex and non-linear relationships. They also play a key role in improving model performance and training efficiency.
What are the advantages of ANN?
ANNs are powerful because they can learn from data and improve performance over time. They are capable of solving complex, non-linear problems that traditional algorithms cannot handle easily. ANNs are highly adaptable and can work with large data sets. They are widely used in fields like healthcare, finance, robotics, and computer vision. Additionally, they can generalize patterns and make prediction on unseen data.
What are the limitations of ANN?
Despite their advantages, ANNs have some limitations. They require large amount of labeled data for effective training. ANN can be time consuming and computationally expensive. The model often behaves like a black box, making it difficult to interpret results. Overfitting can occur if the model learns noise instead of patterns. Proper tuning and validation are needed to achieve good performance.
Where are ANNs used in real life?
ANNs are used in many real-world applications. In healthcare, they help in disease detection and medical image analysis. In finance, they are used in fraud detection and stock prediction. Voice assistants and chatbots use ANN for speech and language processing. They are also used in recommendation systems like Netflix, Amazon. Autonomous vehicles and robotics also rely on ANN for decision making.
What is backpropagation in ANN?
Backpropagation is a training algorithm used to update the weights of an ANN. It works by calculating the error between predicted and an actual output. This error is then propagated backward through the network. The weights are adjusted to minimize this error using optimization. Like gradient descent, backpropagation helps the network learn efficiently and improve accuracy over time.
What is the difference between ANN and deep learning?
Artificial neural network is a broad concept that refers to neural network models with one or more layers. Deep learning is a subset of ANN that uses multiple hidden layers to learn complex patterns. While basic ANN are suitable for simple tasks, deep learning models handle large and complex data like image and videos. So what is clustering in machine learning?
Clustering is an unsupervised learning technique which is used to group similar data points together. It does not require labeled data for training. The goal is to find hidden patterns or structures in the data set. Data points in the same cluster are more similar to each other than to others. It is widely used in data analysis and pattern recognition.
How does clustering work?
Clustering algorithms analyze the similarity or distance between data points. Based on this, they group the data into clusters. Different algorithms use different methods like distance measures or density. For example, k-means groups data based on centroids. The process continues until the cluster becomes stable.
What are the types of clustering methods?
There are several types of clustering methods in machine learning. Partition-based clustering, like k-means, divides the data into fixed clusters. Hierarchical clustering builds a tree-like structure of clusters. Density-based clustering, like dbScan, groups dense regions. Each method is useful for different types of data.
What is k-means clustering?
K-means is a popular clustering algorithm. It divides the data into k number of clusters. Data points are assigned to the nearest centroid. The centroids are updated until the clusters stabilize.
What are the advantages of clustering?
Clustering helps discover hidden patterns in data. It does not require labeled data, making it flexible. It is useful in customer segmentation and market analysis. Clustering simplifies large data sets into meaningful groups. It also helps in decision making and data understanding.
What are the limitations of clustering?
Choosing the right number of clusters can be difficult. Results may vary depending on the algorithms which are used. Clustering may not work well with noisy or complex data. Some algorithms are sensitive to initial values. Interpretation of clusters can sometimes be challenging.
Where is clustering used in real life?
Clustering is used in customer segmentation, in marketing. It helps in image segmentation, in computer visions. In healthcare, it is used for disease pattern analysis. It is also used in recommendation systems and search engines. Social network analysis also uses clustering techniques.
What is dbScan clustering?
dbScan is a density-based clustering algorithm. It groups points that are closely packed together. It can identify noise and outliers effectively. Unlike k-means, it does not require the number of clusters beforehand. It works well with irregular shaped clusters.
What is the difference between clustering and classification?
Clustering is an unsupervised learning technique. It groups the data without predefined labels. Classification is a supervised learning technique. It assigns the data to predefined categories. Clustering finds structure while classification predicts labels.
How do you evaluate a performance of a clustering algorithm?
Clustering performance is evaluated using matrices like slot score and Davis-Baldwin index. These matrices measure how well data points fit within their clusters. A good clustering has high similarity within clusters and low similarity between clusters. Visualization techniques like scatter plots also helps in evaluation. Since clustering is unsupervised, evaluation is more challenging than classification.